What's up, Probability Rockstars? It's Miss Sorensen with video 26, Probability Distribution Table. All right, let's get started. You flip 2 coins and you win $10 for each heads that you flip. Create a probability distribution table for this situation. Now, what is a probability distribution table? Well, a probability distribution table basically outlines every single possibility and the probability that is related to each of those possibilities. So for example, in this particular problem, we're talking about flipping 2 coins. And when you flip 2 coins, what are all the possibilities? Well, you've got heads, 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 tails, tails, heads, and tails, tails. But more importantly, you need to read the question carefully. It says that you win, and this $10 doesn't matter, but you win for each heads that you flip. And you should also recognize here that this says the number of heads flipped. Well, if you are flipping a coin twice, what are the possibilities for the number of heads flipped? Well, look at this example right here, the tails, tails. How many heads were flipped on that one? 0. How about for these 2 situations right here? How many heads were flipped for both of those? That was just 1 heads was flipped. And then you've got this situation here where you won twice. The number of heads flipped was 2. So we have exhausted, meaning we've covered absolutely all the possibilities. And what this wants on the right side is the probability of each of those things happening. Okay, so how many times would we get 0 heads? What's the probability of that? Well, there's 4 situations here. And how many times do we get 0? Well, this would be that case. That's a 0 case. So that would be 1 case out of 4. And then how many times do we get 1 heads? Well, this is a 1 heads and this is a 1 heads. So these are 2 cases out of the 4. And how about how many times do we win twice? Well, the probability of that is just this 1 situation right here out of the 4. So this is a case where we win twice. So that's just 1 case out of 4. And obviously we should reduce all of our fractions so that 2/4 becomes a 1/2. Now, what do you notice about these probabilities if you were to add them up? You should get 1. And you don't need to put that in your probability distribution table, but that's a really nice way to check your work. All right, let's move forward. Create a probability distribution table for rolling 2 dice and their sums. Well, remember, this is asking us to list all possibilities. So what are all possible sums? Well, we've got 2, we've got 3, we've got 4, we've got 5, 6, 7, 8, 9, 10, 11, and 12. So those are all the possibilities. And now on this right column, I'm trying to figure out what the probability of getting each of those possibilities is. Well, how many possibilities total do we have? If you look at the blue, these are all our possibilities, and there's 36 of them, if you were to count those up, or do 6 by 6. And so how many 2s are there out of the 36? There's 1 out of 36. And interestingly enough, there's also 1/12, so that would be as well 1 out of 36. Okay, how many 3s are there? There's 2 out of 36. Now, what does 2 out of 36 reduce to? Well, of course, that would be 1/18. And you can see here as well that 11 also is going to be the same answer at 1/18. All right, what's next? We've got 4s. We've got 3 4s out of 36. 3 divided by 36 reduces to 1/12. And this is also going to be 1/12 here as well. How many 5s do we have? We've got 1, 2, 3, 4, 5. Oh, just kidding. We've got 4. So we've got 4 out of 36, which reduces to 1/9. And we know that pattern is also going to be down here as well. That's not always true, but you can see that pattern's true on our table. All right, how many 6s do we have? 1, 2, 3, 4, 5, and that's it, 5. So that's going to be 5 out of 36, and that does not reduce. And 8 is going to be 5 out of 36 as well. How many 7s do we have? We've got 1, 2, 3, 4, 5, 6. 6 out of 36. Well, what does 6 out of 36 reduce to? It reduces to 1/6. And so you can check your work if you'd like, but these should all add to 1 because we've covered absolutely every single possibility. So just to remember this, the probability distribution table lists all possibilities. These are all your possibilities, and that these are all your probabilities of each of those possibilities. All right, Ms. Sorensen has a candy drawer. There are 34 Reese's and 26 Twix bars. You pull out 2 candies. Let R be the number of Reese's and create a probability distribution table for this situation. Okay, if you're pulling out 2 candies, how many possible Reese's could you get in your hand? Well, you could pick out 2 Twix bars, so that you could have 0 Reese's. You could pick out 1 Reese's and 1 Twix, or 1 Twix and 1 Reese's, so you could have 1 Reese's. And then what about if you pull out both Reese's, so you could have 2? Now, I'm well aware that I say Reese's strangely. I think it's an East Coast thing, but I think I say it perfectly. All right, now back to it. What's the probability of getting 0 Reese's? Well, that's the same thing as getting a Twix and then a Twix. Isn't that 0 Reese's? 2 Twix? Yeah, sure is. So we have to go back to dependent probability and say that the probability of getting a Twix is 26 out of 60 candies. But then you pull out a Twix and you're left with 25 out of 59. And that reduces to 650 over 3540. We can drop the zeros and also divide by 2, I believe. That reduces to 60. Oh, no, we can't divide by 2. Just drop the zeros. 65 over 354. All right, now what's the situation where we get 1 Reese's? Well, that would be the probability of getting a Reese's and then a Twix, or the probability of getting a Twix and then a Reese's. And so we've got 2 situations here, and we're going to have to add those probabilities once we're done. All right, what's the probability of getting a Reese's? That's 34 over 60. And then getting a Twix is going to be still 26, but now we're down to 59 candies. And that's going to give me roughly 884 over 3540. Okay, now what's the probability of getting a Twix and then a Reese's? That's going to be 26 out of 60. And then you pull out a candy bar and you're left with 34 Reese's out of 59. And this is going to give you 884 all over 3540. Okay, so we have to add up these 2 values. So I'm going to add up 884. Okay, and I get 1768 divided by 3540. Okay, and then I'm going to go ahead and press math fraction, and that's going to reduce to 442 over 885. Just reduce this fraction right here. All right. The next thing right here we've got is the probability of getting 2 Reese's. So that'd be the probability of getting a Reese's, comma, Reese's. So that's going to be 34 over 60. We pull out a Reese's. Now we're down to 35 Reese's out of 59. And that's going to give me 1122 over 3540. That reduces to 187 over 590. And that's it for this problem. Let's try another one. All right, we're playing cards, and you pick out 2 cards. Let R be the number of red cards in a deck, and B be the number of black cards. Create a probability distribution table for this situation. Okay, so if you pick out 2 cards, you could have a red, you could have a black black, you could have a black red, or you could have a red black. So given those situations, how many possible situations are there for picking out a red? Remember, you've got 2 cards. Well, you could pick out 0 reds, you could pick out 1 red, and you could pick out 2 reds. So let's go ahead and calculate this probability. If I'm trying to get 0 reds, that's the same thing as saying the probability of black, black. Well, that's going to be 26 out of 52. And you're picking out a black, so you're down to 25 over 51, which gives us 650 over 2652. And I put that in my calculator, I reduce it, and I get a nice friendly 25 over 102. Now let's actually do this one next, and then we'll deal with the harder one last. I've got a little trick for you as well. Maybe you've thought of it already. What's the probability of getting 2 reds? Well, that's going to be probability of R. Well, that's going to be 26 over 52. And then you pick out a red, and you're down to 25 over 51. And notice that that's the same thing that we had above. So that's also going to reduce to 25 over 102. Now you certainly could break this one up right here into red black, then black red. But what if I told you there's a much easier way? Well, that easier way comes from the fact that what should all 3 of these things add to? They should add to 1. So if we add these 2 values and then subtract them from 1, we will get our answer. And I believe that that's a lot easier if you are good at fractions. So let's add these 2. 25 plus 25 is clearly 50. They've already got a common denominator of 102. So that's what I get when I add those fractions, and I'm going to subtract them from 1. Well, how can I rewrite 1? I can write it as 102 over 102. We've got to keep that common denominator of 102, and I'm left with 52 on top, and that's not reducible. Oh, it looks like it is reducible. 52 over 102, that can be divided by 2, and that's going to give me 26 over 51. And if you look at these, this is pretty close to a fourth, pretty close to a fourth, pretty close to a half, but not quite, right, because you're pulling cards out, and that does impact those second pulls. All right, that's it, folks. Hope you enjoyed the video. Have a great day.